Welcome back to Understanding Human Anatomy. In this video, I'm going to talk about axial musculature, the axial muscles. And I'm going to do it in very general terms. We're not going to go through each and every individual muscle. Just look at them as broad groups of muscles. If we look here and at our little piece of spinal column, let me draw in some muscles that are inserting on the spines of the vertebra. Now, we're not going to name these muscles right now. We're just going to consider them as a group. But you see muscles running down the back. They're originating someplace below the spines of the vertebra, and then they are inserting onto the spines of the vertebra. They might insert onto the lamina of the vertebra and also onto the transverse processes of the vertebra. But they're on the posterior side of the vertebra. So muscles on the posterior side of the vertebra are called postvertebral. Postvertebral muscles. Now, some of these muscles that are considered postvertebral muscles would be muscles like sacrospinalis, which is in fact a group of muscles. The semispinalis, multifidus muscles, all postvertebral muscles. Now, when dealing with these muscles, there is a general rule. And that is, all the postvertebral muscles extend the spinal column. They extend the spinal column as a group. The other thing we should consider is the innervation. These muscles are innervated by the posterior ramus of the spinal nerve. Now, when muscles are innervated by the anterior posterior ramus by the spinal nerve, just by the spinal nerve itself, we refer to that as segmental innervation. Segmental innervation. And when we have muscles that are innervated this way, it means you don't have to memorize which nerves supply the muscle. We know that they are the nerves that are in the immediate vicinity of the muscle, branches of the spinal nerve. They do not have individual names. So the postvertebral muscles extend the spinal column, and they are innervated segmentally by the posterior ramus. Let's look at the anterior side. There are muscles on the anterior side, and again they can attach to the pedicles, to the transverse processes, or to the body. Just to keep the diagram simple, I'm going to draw them in attaching to the body, or the bodies of our short amount of vertebra here. And again, these muscles are innervating inferior to their point of attachment. Their other attachment is inferior to these attachments onto the vertebra. These muscles are on the anterior side, and they are called prevertebral muscles. Muscles in this group would be muscles like the rectus abdominis. That's the muscle that forms the six-pack in well-conditioned individuals. Now this muscle doesn't attach to the vertebral column, it attaches to the sternum, but it is definitely prevertebral. We have muscles like longus, colli, a muscle of the neck that does pretty much run up the vertebral column attaching to the bodies of vertebra. These are the prevertebral muscles. All the abdominal muscles are prevertebral. All the intercostal muscles. All of them are prevertebral. Now, we had a rule for the postvertebral muscles. We'll have one for the prevertebral muscles. The prevertebral muscles flex the spinal column. All of them are flexors of the spinal column. They cause us to bend forward. Their innervation is also segmental, but the prevertebral muscles are innervated by the anterior ramus of the spinal nerve. So again, segmental innervation, but the prevertebral muscles are flexors. They're innervated by the anterior ramus. Postvertebral muscles are extensors. They are innervated by the posterior ramus of the spinal nerve. Now, in the next slide, what I want to do is look at the axial muscles from the posterior point of view. The rule I gave you that prevertebral muscles flex the spine and postvertebral muscles extend the spine is true when the muscles on the left and right side of the body act at the same time. They act together. This doesn't always happen. Sometimes one side of the body will act and the other one will remain relaxed. I'm going to use a posterior view of the spine to illustrate this. And so I'll be talking about postvertebral muscles, but bear in mind that prevertebral muscles can do similar things depending on the way they're attached and the direction of their muscle fibers. Now, let's start with a muscle that is attaching to the transverse processes of these vertebrae. So we'll draw in some muscle fibers like this. And I'm drawing this deliberately fairly wide. It will depend on the individual muscle how wide the attachment is. But now this muscle, and it doesn't matter what name, it's a generic muscle for our point. If only the right side, if only the side I've drawn in is active and it contracts, what it will do is cause the spine to flex to that side. And that is an action or a muscle activity that is called lateral flexion. And this can be an action of a postvertebral muscle or a prevertebral muscle if only the left or right side muscles act at any one time. If the left and right sides act together, then this being a postvertebral muscle I've drawn in here, it would extend the spine. But if only one side acts, it's going to flex laterally. Now, these pre- and postvertebral muscles also can act to rotate the spine. And there are small muscles, for example, that run from the lamina of one vertebra to the transverse process of the vertebra just above. So it'd be running like this. I'll draw another one in here. And we'll draw a third one in just for good measure. Now, these muscles, when they contract, they will pull the transverse process around posteriorly, and the vertebra will rotate on its body, or about its body, to turn so that the body will turn to look to the same side as the muscle is contracted. So it would cause the body to turn in this case to look to the left. So it causes rotation to the same side as the muscle, or to the ipsilateral side. Okay. Again, although I haven't drawn them in, if we drew in these same muscles on the other side and they acted together, left and right, they will still extend the spine. But acting individually, they cause rotation of the spine. Now, there are also muscles that run from lateral positions over to the spine of a neighboring vertebra. And we'll try and draw some. We'll try to draw some in here. I have one taking origin on transverse process going over to the neighboring spine, like so. Here's another one. And a third one. Okay, these muscles, again, if the left and right side of the body are acting together, these muscles will extend the spine. But if the left and right muscles are not acting together, only one side is acting, it again will cause rotation, but now the rotation will be to the opposite side. These muscles I've drawn are on the left side of the body. It will cause the body to look to the right. The spines of the vertebra will be pulled closer to the transverse process at the origin of the muscle. And because of that, the front of the vertebra will turn the other way. This will cause rotation to the opposite side of the body, That is the contralateral side. In summary, the axial muscles lie either anterior or on the anterior side of the vertebra. These are prevertebral muscles. They flex the spinal column when left and right sides are acting together, and they are innervated segmentally by the anterior ramus of the spinal nerve. Muscles that lie posterior or on the posterior surface of the vertebra are called postvertebral muscles. Again, when both sides are acting together, they extend the spinal column, and they're innervated segmentally by the posterior ramus of the spinal nerve. When pre- or postvertebral muscles act unilaterally on one side or the other, they will cause lateral flexion or rotation, depending on the muscle's attachments. Thank you for your attention.